Up until now, we have examined blind spots from a psychological angle, but sometimes what looks like overconfidence is not psychology. It is statistics. Module 6 begins here, with one of the most misunderstood concepts in data interpretation, regression to the mean. The term sounds complex. The idea is not. Regression to the mean simply means this. Extreme results tend to move closer to average over time. That's it. If something is unusually high or unusually low on one occasion, the next measurement is likely to be closer to the average, even if nothing real changed. Let's make it concrete. Imagine a student who performs exceptionally poorly on one test, much worse than usual. The next test, they improve. Was it because of a miracle? Probably not. The first result was unusually low. Statistically, the next result had a high probability of being closer to their normal performance. The same applies in the opposite direction. If someone performs exceptionally well, far above their typical level, the next performance often drops slightly, not because they lost ability, but because the first result included randomness. Extreme outcomes often contain two elements: skill and luck. Luck, good or bad, rarely repeats at the same intensity, so the next result drifts back toward the average. That drift is regression to the mean. Now here is where it becomes dangerous. Humans dislike randomness. We prefer stories. If performance improves, we search for a cause. If performance declines, we search for blame. But sometimes there is no meaningful cause. There is statistical normalization. For example, a manager criticizes an underperforming employee. The next month, performance improves. The manager concludes, criticism works. But performance may have improved simply because the previous month was unusually bad. Similarly, a team celebrates a record-breaking month. The next month, results decline. Leadership assumes motivation dropped. But the record month may have included favorable external factors that naturally stabilized. Without understanding regression to the mean, we attribute randomness to skill or failure. This matters deeply for the Dunning-Kruger discussion, because sometimes perceived overconfidence patterns are amplified by statistical effects. When low performers score extremely poorly on one test, their next score often improves naturally. Researchers might misinterpret that improvement as learning, but part of it may simply be regression. Likewise, very high scorers may show slight decline on retesting, not because they misunderstood their ability, but because extreme scores tend to soften. If we do not account for regression to the mean, we risk misdiagnosing patterns. We may overestimate intervention effects. We may underestimate stable competence. We may confuse fluctuation with growth or decline. The key lesson is this: not every change has a psychological cause. Sometimes change is statistical gravity. So, how do you apply this insight? When you see extreme results in your performance, in your team, in your investments, in your habits, pause before constructing a story. Ask, was this result unusually extreme? Could randomness be involved? Am I interpreting fluctuation as transformation? Regression to the mean does not eliminate psychology. It refines it. It reminds you that calibration requires both emotional awareness and statistical literacy. Confidence must be informed not only by feeling, but by pattern. In the next lesson, we examine another distortion: scale effects and estimation bias. Because sometimes the illusion is not in the mind, it is in the measurement. Calibration is becoming sharper, and sharper calibration produces steadier confidence.